I'm going to be very direct here, and I just ask people to introduce themselves to save time. So I think we'll just take it in the running order really that we see here. So Reid, you were here early enough, so you deserve to go first. So Reid, would you like to say something about yourself, and and perhaps Ashton as well, to kick the thing off?
While he's setting up, we're both from the University of Toronto, and sort of this is work. I'm his PhD student that I've been working on for a little while. That is also sort of in collaboration with Microsoft Research and Cornell.
Yeah, so can you all see my screen now?
Yeah, it looks
excellent.
Great.
Okay, great. Yeah, so that was a good intro. Thank you, Reid. Yeah, so we're super excited to present our project MaiaChess, which is a human-like neural network chess engine and analysis framework. So this project, being kind of in chess and AI, is kind of draws on a long history actually. So if you look at the pantheon of AI greats, you'd be hard pressed to find one that didn't work on chess. Alan Turing, the godfather of computer science, he devised the first chess playing algorithm. This is actually before the first computers could even run it. Claude Shannon described minimax the next year, and then chess, as we probably all know, kind of became this long-standing AI problem. So people referred to it as the Drosophila of AI, like the fruit fly, in which we could kind of study intelligence and how to model it. But then people started to lament that computer chess had developed much as genetics would have if we had concentrated on making really fast fruit flies. So we'd have some science, but really would just kind of be engaging in races. And so that's kind of the way that computer chess developed a little bit. It's been obviously some like incredible work, some that led to some watershed moments, not only in AI, but in society in general. So, obviously when Deep Blue beat Kasparov, that was worldwide front page news. And then a couple of years ago, AlphaZero, kind of the same thing, kind of gave us a completely different way of thinking about computer chess. So chess AI has been kind of superhuman, like literally better than any human for at least 15 years now, maybe even 20. But I think the argument is that we kind of drifted away a little bit from the humans playing chess. So for example, I'll give you an example that I'm sure everyone here is familiar with. When you analyze chess positions or your own games with strong chess engines like Stockfish, they're really kind of telling you what they would do as 3,400 rated calculation beasts. And they say in this position, I would play d5 because I know that after pawn takes pawn, I'm going to play the only move knight b4, not the natural but game losing knight e7, because knight b4 has this knight d3 check idea. It lets you take back the pawn. But would you, if you were teaching an 1100 rated player, would you really recommend them to play d5? Like they need to follow up the. They need to know this kind of very kind of deep, sharp idea just to maintain the balance, especially when there's an equally good move but much more natural move, d6 in this game. So the AIs that we have, they're not really geared towards people. Another example is when you want to play against AI. So first of all, those super strong engines, obviously, they're just not fun to play at all. You just get crushed. And then when you have engines that play roughly at human level, they do so by in some pretty unsatisfying ways. So I was playing Stockfish level 4 a couple of days ago, pretty natural position. I played the move bishop takes knight, and then Stockfish played g3. And then I moved the bishop away and I won the game easily because it gave me a piece for free. And I didn't learn anything, didn't really have that much fun. This just isn't what chess feels like. So again, when you play these sort of handicapped engines now, it's not that fun, not that insightful. So the question that we're coming to this project with is, how can we bridge the gap between artificial and human intelligence? And it turns out that chess is a perfect model system for answering this kind of broader AI question. So chess has always been kind of on the leading edge of AI, and this I think is same way here. So AI has reached superhuman performance at least 15 years ago. You know, you'd be hard pressed to find other domains for which that's true. You know, things are starting to happen in certain kind of like medical diagnosis domains and stuff like that, but nothing really like chess where it's been super clear for a long time. There's massive data sets of human play in chess, obviously, so we have the data that we need to do this in an algorithmic way. And there's a wide range of human skill levels. So, you know, chess just admits this crazy huge gulf in skill between, you know, ranked beginners and very strong chess players, which means that we can try and characterize human skill at different levels. And then we can try and learn, you know, what it takes to get from one level to the next. So the overarching question that we have here is how can we algorithmically capture human style in chess, and we operationalize this question in a very simple way that we can build on in future work, which is can we predict the next move a human at a specific skill level will make in a real game? So that's a question that we focus on, and I'll turn it over to Reid to explain how we did that.
Yeah, thanks, Ashton. Yeah, so to start with, we have this amazing data set from lichess.org. They've got almost 2 billion games played between humans at various skill levels. So it's very good for analyzing sort of regular players playing chess. So next, we were building also on this sort of framework of AlphaZero, sort of these reinforcement learning, deep neural network-based chess engines. And then specifically, we have this great opportunity to use Leela chess, which has this community-driven effort and has a bunch of models that are all public and accessible. So next, we were then trying to figure out, is this already sort of done? Are there already models that play like humans available? If we take sort of depth limited stockfish, which was what Ashton was playing against at the beginning, or if we take some Leela models that have been basically not trained fully. So if you take Leela sort of early generations of the sort of self-play, self-learning procedure, it actually plays very weak. It plays like a very weak engine. And then that sort of gets to the next sort of a point, which is these attenuated engines, we have sort of 2 ways of considering if they play like humans. First of all, is sort of the general level of the rating. So if you take stockfish, you can sort of attenuate it, you can reduce its computational ability until it gets to win 50% of the time against rating 1,500 players. But does it actually mean it plays like a 1,500 player? And that sort of gets to our sort of more specific way of measuring that, which is this granular human decision making. So do they match the move level? So to start that, we had to create a sort of data set and a way of evaluating it. To do this, we went through the lichess data, looked at all the games from December of 2019, and we just divided them into these bins. So we have, we just went 100 rating points wide. So each bin is between both players with similar ratings. And we created these bins between ratings 1,100 and 1,900. So there's 9 of these bins in this initial testing data set. And then our exact measurement is this move matching accuracy. So for every single game in these 10,000 games at this specific rating, how well does the model predict the exact next move that was made? So the top 1 accuracy, yeah. And then, so what does this look like? Next, yeah. So we just are gonna have this plot. We have this rating on the x-axis, and then we have this model matching on the y-axis. And then in theory, we initially sort of naively, what we want is just like a high bar horizontal line at the top. But if we think about that a little bit more, we're trying to predict human decision making. This is not sort of a deterministic process. Individual humans sort of just don't even make the same decision every single time. So we know we're never going to get 100% accuracy. And then additionally, if we're looking at these different ratings, we know sort of by definition that rating 1,100 players make different decisions than rating 1,900 players. So in fact, sort of our sort of preferred model will have some sort of like distribution over these that is not uniform. And you'll have some sort of cutoff as you get further away from your targeted rating. So that sort of leads us to the conclusion that we don't want a single model. We want some sort of parameterization or set of models to try and predict the next move of humans. So we get to sort of, this is sort of what we want. So to start with, we looked at stockfish. So stockfish, we're all familiar, we can sort of limit its depth. And then we were just measuring its next move accuracy. As you can see here, it's okay. It gets like 41% at predicting the next move made on some very high, on high-rated players, we get some interesting results where it's just more accurate the better the players are. So strong players play better, play closer to stockfish is sort of what we were expecting to see. We do see one interesting thing, which is very weak stockfish. So depth one stockfish is actually a bit more accurate than depth 7, sort of like a medium depth. But as you get even deeper, as stockfish does even more computation, it actually beats that. So we get this sort of interesting non-monotonicity in this analysis. And then if we go to Leela, so Leela shows what people were sort of expecting, where it had this sort of reputation of playing more humanly. And we see that as it's sort of beating stockfish, particularly at the low levels. So it's, if you take the strongest Leela in our set, which was on their internal metrics was a rating of 3,200, doesn't quite translate to real humans ratings, but it's generally better at predicting the next move a human will make than stockfish, but it's not really calibratable, it's not really tunable. There's no way of saying this Leela plays more humanly at this rating than some other one. So that sort of gets to what we were looking at, which is we called Maia. And our specific idea is to learn from humans instead. So Leela does not learn from humans. We are trying to predict the next move a human will make. And to do that, we're looking at human games. So just to make it more explicit, like Leela is very much what we're based on, our code base, and it's sort of what we're directly comparing against. We are learning from human games. Leela never sees any humans playing. Maia is, and we are trying to play like a human. We're not trying to beat tournaments. We are trying to basically get down to 1100 rating play. And we do this, and I'll talk about it a little bit in the future, but basically our model acts as a classification instead of as a reinforcement learning system. And it doesn't do any tree search. So it actually is just a neural network. It doesn't actually have to do any sort of like discrete series of computations to predict the next move. It's just a single matrix operation. So let's see how it goes. We then created a bunch of different models. So we have one Maia model for each of the rating bins we were targeting. And they're all trained on 12 million games. And these games are set up the same way as our rating bins. So the games are between both players within the same rating. And that's sort of what Maia sees to train itself. And then these different models are then played on our testing set. And we see, first of all, that we get much higher move prediction accuracy. So we're above 50% if we're in the targeted range. And at the low end, we're getting about 46%, which is still higher than either Leela or stockfish. And then we get this wonderful sort of tunability. So if we want to predict the next move that a rating 1100 player will make, we actually use the 1100 targeted model. And we get this sort of rough Gaussian distribution over these ratings. And then sort of just, if you want to see, compare it to all the models, we then, here's just sort of the plot in general. You can see we're about 10% more accurate on what we're actually targeting. And then our 1900 rating model even continues to do quite well all the way up to 2,500 rated players. But yeah, you can see the stockfish and Leela are sort of still sort of like getting monotonically up. But yeah, that's good players are playing closer to stockfish, but we happily for us are still sort of trying to beat them. And then sort of getting more into the details of, as I said, we didn't do any reinforcement learning search. So we actually did some testing on that. And basically, if you do this sort of tree search, if you try and do some more computation, the model gets better at playing the game of chess, and it does worse at actually playing like a human. So I think that's sort of the main handicap of these other models, is they're just playing too well. They're playing too strong. Additionally, the Maia sees the last sort of few moves that was made by the player's targeting. So it's using that information also. And if you just give it a single board, its accuracy dropped by 2 or 3%. So it actually is sort of gaining insight from the previous couple moves the player was making, which I think is really interesting. Yeah, and now we sort of moved on, and we sort of made this announcement, and we have a couple of bots playing on MaiaChess, and in the last week, they've very much taken off. So we have these 3 bots, and they've played over 40,000 games in the last basically 4 days on MaiaChess. Had some amazing reception. And we've been able to start calibrating where these models' ratings are relative to the actual humans on MaiaChess. And to quite the surprise of players on MaiaChess, the one that was trained on 1100 ratings is significantly stronger than 1100 because it's basically playing like a committee. It's not actually making mistakes at the same rate of 1100. It's sort of making the average move, not the exact move that a human of that rating would make. So we'll go next. Yeah, we just got this great reception. We got over 7,000 players playing them. Mostly this reception is from sort of this press coverage from Microsoft from this conference, and was sort of amplified by some YouTube videos from one of the top YouTube players of chess. And yeah, if you want to play them, they're there. I think Ashton's going to talk some more about sort of what the implications are of this work.
Yeah, thanks a lot, Reid. I'll just finish up with where we think this is going. So it's, of course, very fun that you can play Maia and it feels human-like. But our main goal with this project is really to try and understand human play and try and help people learn in like a smart, data-driven way. And I think the interleaved kind of plot that Reid was talking about there, where we actually target skill levels in a very kind of targeted way, it means something pretty deep about chess, actually, that I wasn't even sure was true before we did this project, which is that you can actually characterize like 1200 rated play. It's not just 1900 rated play with more errors mixed in, and therefore you can't really predict it uniquely well. We actually can predict it in this targeted way, which means that there is this kind of like reliable, predictable, and maybe even algorithmically teachable difference between one skill level and the next. So if you're at 1200 and you want to get to 1400, we now have models that characterize that kind of those two play styles fairly well, and therefore we can compare what the differences are. So for example, if you look in a position like this, the player in the game made the tempting but wrong move b6, pushing the pawn, attacking the queen, looks all good to maybe some lower rated players. But after queen takes c5, basically the advantage is gone. And Maia levels 1100 through 1400 all correctly predict that that's what the player is going to play. But then after about 1500 all the way to 1900, they start predicting that the player will play the natural and correct move, pawn takes pawn, kind of opening the queen side. So, the Maias have figured out that there's, the mistake b6, is probably around a 1400 level error, and after 1500, you stop making that kind of mistake. So if we kind of aggregate that over all the positions that we ever see, we can actually try and understand human error and develop tools to actually target the particular errors that players are making. So the cool thing about Maia is that it predicts mistakes surprisingly well. So on the right of this plot is correct moves when the difference between the human move and the optimal move is very small, and on the left are like these horrific, like dropping a queen cold blunders. And even in that case where you make a terrible mistake, Maia's not just predicting that a player will make a bad move, but it predicts the exact move that they will make even 25% of the time. And our performance increase relative to other models is actually better for mistakes than it is for correct moves, because it's easier to predict correct moves than it is to predict errors. Yeah, so just to wrap up, so we have some time for questions. We introduced Maia, which is a human-like neural network chess engine, captures human style at targeted skill levels in a way that previous models don't. You can play it online right now. And what's coming next for us are these algorithmic and data-driven improvement tools driven by Maia. So thanks so much for your attention. We wrote a research paper and published it earlier this year. You can check it out for free online. You can go to MaiaChess.com if you want to learn more about our project. And you can play the bots on MaiaChess. And yeah, look forward to taking your questions, if you have time for that.
Maybe. Yeah. Do you want to take down your screen,
Sure.
Ashton? Yeah. Yeah. Okay. So a couple of questions then, because what I want to do is we'll get a flavor for each of the contributors, and then we will pull it all together at the end. Okay. So I'm looking for the chat to see if any questions are going to pop up. in the. Oh, people have not been very diligent in putting forward questions. Okay. Well, look, Martin. We'll come back to Martin Bennedik. You have a presentation, a short presentation. You said. Would you like to?
Yes. Okay.
We'll come back and we'll ask we'll ask all these questions together at the end, if that's all right with you guys. Right? Okay.
Sure.
Yeah. Thank you. Yeah.
Okay. Can you see my screen?
Yeah.
Okay. Okay. Hello. My name is Martin Bennedik. I'm an independent software developer. And I made a little website called chesspuzzle.net with chess puzzles. And I'm going to talk about chess puzzles and technology. Okay, so what is chesspuzzle.net? Well, first of all, it's a website where you can solve chess puzzles. Yeah, here's a screenshot of the website. I'm not going to do any live demos today because this is like a limited time demo. Yeah, the website has been started 4 years ago. And it's been growing steadily since. So where are these chess puzzles coming from? They're coming from an algorithm that I built. And the algorithm has as input tournament games from PGN files. So here on the left, you see an example from a recent game from the chess.com speed chess tournament, Caruana versus Duca. And the output of the algorithm are chess puzzles. So here on the right, you see an example generated from this game. So it's a nice checkmate puzzle. Yeah, in the solution, the first move is rook d5. So that's quite nice because you have to put your knight behind your rook. It's quite a unique motive. Okay, and then the third thing that makes up chesspuzzle.net is an algorithm that automatically tags chess positions and chess moves. So here in our example, on the left, you can see the tags on the right. So the position was tagged as a middle game position. Then the second move, rook takes c3. Got the tags sacrifice, piece sacrifice, rook sacrifice, deflection. That gets more interesting because it has to look at not the one move, but the combination of moves. Yeah, deflection into checkmate and blocking the escape square. So that means that after rook takes c3, white is forced to recapture. This knight takes c3 and blocking the escape of the own king. Okay, so why did I build another website with chess puzzles? There are already many websites with chess puzzles. Even many of them generate the puzzles automatically. Yeah, so a couple years ago, I came back to over-the-board chess after having played correspondence chess for a couple years. And yeah, I was using the existing tactic trainers to try to get back into shape. And yeah, for a time I thought it was great. But when I came to the more difficult puzzles, yeah, I found some problems with the existing solutions. And yeah, then I had the idea to make a better algorithm for that. And yeah, I've been working for the last 4 years on that. And here's an example from another website. It's a screenshot from a Chessable tactics course. So Chessable is, of course, a great website. I'm actually working with them. But here this is a classic checkmate puzzle from a 1937 game. And here you can see that Chessable has only one solution. So it's a nice queen sacrifice where you have to draw out the opponent king and then drive the king back to where it came from and checkmate it there. It's really a nice classic puzzle. So my algorithm generates all the possible solutions. And here you can see the solution tree. So I'm not going to show all of them now. That would take a lot of time. But you can see there's a lot of ways to checkmate here. And yeah, actually, if you only allow one solution and the players will make another move, that is also good. Yeah, they are always sending you an email and are not happy with that. Okay, here's another example where on the second move, I'm now allowing 2 options for these puzzles. So here you can see this is a classical bishop sacrifice on h2. And on the second move, you can either play queen h4 or rook h5. And then on the third move, the other. So it transposes, but there's like 2 different options on the second move. So, and there's a lot of puzzles like that where you can transpose or use one knight or the other knight on the second move. Yeah, then another area that I'm researching is the reply moves. So Delia told me that in chess problem solving competitions, you actually have to write down all the good reply moves. But yeah, when you solve a puzzle interactively, there's only always one reply move. And here's an example from the chess.com Puzzle Battle World Championship. I don't know if you saw that. It was an interesting competition where 2 players had to solve the same set of puzzles. And whoever was faster or got more of them right won that match. And yeah, here in this puzzle, black plays king h6, threatening mate with g5. And then white plays g4, making room for the king to escape via g3. And then black plays queen g1, taking away that escape square. And then in this World Championship match, white played queen e3 and sacrificing the queen. And turns out, according to Stockfish, that's the best move because it's like mate in 3. But yeah, it just drops the queen immediately and the puzzle ends. And yeah, so on chesspuzzle.net, we have the same puzzle. It's from a tournament game. So yeah, it happens that we have the same puzzles. Yeah, and there white just captures the pawn and is mated 2 moves later. Okay, and then there's many other things that I'm researching, trying to improve these puzzles. Yeah, I'm not going to talk about all of them now because then, yeah, the talk would take many hours. Yeah, so but more about the automated tagging of the chess positions and moves. Yeah, so here's a screenshot from chess.com where they actually use like a wisdom of the crowd feature and people can vote for the motifs. But yeah, actually, when I took this screenshot, half of the motifs were wrong. So this doesn't really work very well. Yeah, so I've got a nice library of motifs. It's already more than 150, and yeah, still working on more of those. So how can we use them? There's a feature on the website called the filter. You can see the filter on the left. So here you can search for specific puzzles. So here I've selected a winning puzzle. So the task is that you should win. The motive should be a knight fork, and the player should be Magnus Carlsen. And the first example that came up was this recent game, also from the chess.com speed championship. Yeah, it's just a simple knight fork winning, but these things happen even in the grandmaster games when they play blitz chess. Okay, and then one step further is that based on these tags and yeah, a huge set of puzzles, there's more than 100,000 puzzles now on the website, it is possible to automatically generate chess content. So here's an example that you already find on the website. It's called levels. And there's like 20 levels, each with a simple tactical motive. And yeah, so if you play this level, you get like 10 puzzles with this motive. And if you play the same level again, you get 10 different puzzles with the motive. So you can always replay these levels and get different puzzles. Yeah, and here's a preview, what I'm currently working on. It's 20 new levels with checkmate patterns. So this one is a bit different. So you also get like 10 puzzles, but you get like the first 2 puzzles is like a mate in 1. Then the next 2 puzzles is mate in 2, and so on. So it gets more and more difficult while you play the level. And yeah, it's also basically teaching you the motive, because you start with the mate in 1 and you're learning the motive while you go. So there's no other instructions, only this little diagram. Okay, here's a preview of some new patterns that I'm working on. And actually, these are patterns that you don't find in any book yet, as far as I know. So it's defense patterns. So this is a very simple example. Here, white is just threatening a fork with knight c7 check. And you have to find the move knight d5 to defend against that. So this is a nice beginner's puzzle. And here's a more interesting example. So it's like a defense against intermediate check. So I didn't even know that this was a possible motive, but the software discovered it. So here the rook on e6 is pinned. But if you take it immediately, it's just a drawish position. Actually, black's pawn up then. But the threat is knight e5 check, and then the king has to move away and can no longer protect the rook. So, and the solution to this puzzle is bishop c3, protecting that square. Okay, one more topic is about beautiful puzzles. So that's something that the machine doesn't really know. What is beautiful and what is not. So, but I have a feature called the daily chess puzzle. So each day I select one puzzle, and this is shared via social media and also on other websites like the Week in Chess to get new users to the website. So how do I do this? Well, currently I just have a very simple SQL script that runs the database, and it's giving a score for each puzzle based on several criteria. So these criteria include number of likes. Then some of these tags I showed you are considered beautiful. For example, a sacrifice. Then if famous players are playing in the puzzle, how difficult the puzzle is, shouldn't be too easy, shouldn't be too hard. The length of the puzzle is also important. Yeah, and here's what it currently suggests as the most likely candidate for a beautiful puzzle. So that's a one-move puzzle where black has to win. Okay, and I think Delia is going to talk a bit more about beautiful chess positions next. Okay, thank you. And yeah, I got to mention that part of this work has been sponsored by Play Magnus and CodeChess. Okay, thank you.
Okay, Martin, if you want to unshare your screen.
Okay.
Right, okay. So I'm conscious that there's been a very raging debate in the chat, but I'm also aware that the debate can take a lot of time, particularly such fascinating topics, and there was a brilliant insight into how Martin produces these very beautiful chess puzzles using artificial intelligence. I'd now like to move on to our next speaker, Delia Duca from University of Brasov in Romania, who is actually using artificial intelligence to identify beauty. So Delia is a chess composer as well. So I think we all look forward to your talk. Do you want to share your screen, Delia?
Yes, I will.
Okay. Good.
Hello, everyone. Nice to see you all for the invitation. It's interesting how the whole debate was actually about what beauty is. I find it very interesting that the first presentation was about making natural moves even for lower levels of playing. This was what I felt also when I played, for example, the Play Magnus app for age 8. And I just took a pawn. I mean, I'm 100% sure that Magnus was not giving pawns even at 8 years old. So the artificial intelligence is not working 100%, was not working 100% correct there, because of course Magnus Carlsen was making mistakes at 8 years old, but not so obvious mistakes. And then what Martin Bennedik is using for the website to identify a more beautiful diagram. Of course, it depends on what type of diagrams we are talking about. If we are talking about diagrams that are from chess games, of course, it's interesting that they were played in actual chess games, but most of the times they don't respect the conditions, the minimum things that we look for in a nice diagram, in a nice composition. For example, we don't have to see a piece on the board that is not doing anything. If you have a piece like this, the composition is not beautiful enough, and it's not going to be awarded in a chess composition tournament. And what I was trying to achieve with my PhD thesis was to first to generate a rating for such compositions. We have a big data of almost 1 million compositions. Some of them can be found on the website Yet Another Chess Solving Database. And we have this big data, and we can use it combined with artificial intelligence to identify exactly what is the score of such a puzzle, if it's a 7, a 730, and combine this with some experts in the domain, and then eventually to make a program that can compose beautiful puzzles starting from nothing. And this is the final goal. Okay, I will try to share my screen now. Okay. Recently, this artificial intelligence combined with big data was used, of course, for cheat detection. That is a very popular subject now, considering that most of the competitions moved to online. And I studied this also because I published an article. Actually, in 2 days from now, it will be published in the Serious Games publication. But for now, I just want to talk a bit about cheating and how they managed to use this artificial intelligence combined with big data for cheat detection. Okay. We thought for a long time that we will use artificial intelligence to play chess better or to learn better, but now the big data is being used for cheat detection also. And there are sensitive issues when we consider playing online and detecting fraud in these online tournaments. If a player is playing for the first time for a game, of course, it's even harder. But when we have big data behind, we can make those anti-cheating software better by identifying a non-plausible move of a player, considering their game history. Of course, we will make mistakes. It's not perfect, but we can find the best possible solution, and we can achieve this using big data. I brought this into discussion about cheating and how they used their millions of games that they played and managed to find a good solution for it. I mean, we are really lucky that at this point we can play online and we have good anti-cheating software compared to other sports that in this time were not able to play at all. And other sports players. And this was possible because of this big data that we have with chess games. And we can find a move that is not plausible for a specific player. What I want to do is to use this big data that we have with already composed diagrams to identify if a composition is beautiful enough, and if it is, then I will just display it. In this small program that I have here, my story is in Romanian, but you will understand. You can just select some pieces that you want. Of course, this is something very basic, and here it says that with the pieces that I selected, we can have a composition if we just move the rook to another place. So I will try with one rook. Okay. Here we can see the solution, but what I'm trying to do here is to compose, starting with some pieces that I want to have, to compose chess diagrams. And it's working. It's composing. If I let it work for 1 hour or something, I have already nice compositions, but they have big issues. Only one aspect is enough for making it not beautiful. So it was easy to make the request for all the pieces on the board to have some influence in the solution. This was easy, but we have a lot of other conditions. And if I try to put more and more conditions to it, and then the chances to have one composed diagram that respects all the conditions decreases very, very much. And here is where I try to use the already composed diagrams and to classify them by using clustering, and then to extract automatically some properties that a beautiful diagram should have. Because at this point, I have to choose between a fast composition but not so beautiful, of course. And if I try to compose something more beautiful, it takes a lot of time. Okay, this was what I'm trying to do. If you have any questions until now. I am currently at the Transylvania University of Brasov, and my PhD thesis is about computational methods for strategic games. But of course, my biggest passion is chess, and this is why I'm trying to apply it for chess.
So you can unshare your screen now, Delia. Find the green button somewhere. While you're finding that, can you just explain to us what you mean by a beautiful chess position as compared to a normal chess position or composition?
A beautiful composition compared to what?
Like a regular one taken from a regular game.
Oh, okay. So I just said, I already said the most important difference is that usually in a composed diagram, you are not supposed to have any piece on the table that is not doing anything, is not participating in the solution. And this request is easy to make it possible. You just remove the pieces that are not doing anything. And then for a non-composer, for a non-solver, just for a regular chess player, it will look like this diagram is not so interesting. White has so many pieces and black usually is lost anyway. But if you look at it from a different point of view, the beauty is in other aspects, not in the winning with white pieces, for example, even if you have just a bishop and a rook. Of course, diagrams that are coming from chess games are interesting, especially because the white and black usually have equal forces, or almost equal forces, or the part that is winning is even lower with the own pieces. But a chess composition usually has a theme. We have hundreds of themes. They can all be found on the yet another chess solving database website. And those chess compositions are usually taking, I mean, as a chess composer, you sometimes spend more than 2, 3 weeks, 4 weeks, maybe 2 months to compose an interesting chess diagram. We even have a World Chess Composing Tournament, and they allow you with computers. So up to this point, it's considered that a computer cannot help you with composing a really beautiful diagram. But I personally believe it can, and it will be done for sure. It's almost the same thing that AlphaZero did in the game, coming with changing completely the way we used to look at chess engines. And it's similar, like I said, also with what my colleagues presented before. It's similar, because we are trying to use artificial intelligence, but in the same time to make it more similar with what a human would do, what a human would consider it beauty. And here we are thinking almost the same. I mean, if you put 5 or 6 judges to look at 10 chess compositions, they will put them almost in the same order. Maybe the 6th one will be 4th or 5, but almost in the same order. We consider beautiful almost the same diagrams that have a nice theme and an unexpected solution. Of course, the first move will never be a check. This is like too trivial and too easy, and so on. Thank you.
Okay, thank you very much, Delia. Would you like to unshare your screen now? Stop sharing. Okay. Thank you. Well, actually, you're still sharing your screen. Yeah.
Yes, I just stopped.
Okay, great. Thank you very much.
Thank
Okay. Again, a very fascinating talk on beauty and the combination of artificial intelligence and human factors. I'd now like to call Pawel. Is Pawel here?
Yeah, I'm here.
Hi,
Can you hear me?
Yeah, right.
Okay.
Can I just,
Hello.
your camera's very low, so we're seeing it from down below.
Well, I'm using an iPad, so this is the only way I can do it. Sorry for that.
I just announced that Pawel was part of our kind of chess startup competition that took place last night, and he was the winner with his Chessvision AI. So I think what he's done is quite remarkable. And Pawel, would you like to just explain what you're doing?
Yeah, of course. So actually, in this presentation, I will be showing what can we do with chess videos. But the startup competition, in the startup competition, I presented the ebook reader. So let me share my screen, and this will be mostly live presentation. So I will be showing live demos of the products.
Always very safe thing to do.
Not very safe, I think, but yeah. Okay, can you see my screen?
Yes.
Okay, so a little bit about me. So I'm the creator of Chessvision AI, and this is basically a collection of tools to analyze digital chess content. So I can really quick show them. So the first one I built is a browser extension. This one here is quite popular. And what it can do is that you can use it to scan chess diagrams from any website, whether it is a regular website, puzzles, chess videos, anything basically. So let's see how it works. So this is a chess.com puzzle. We open the extension. There are some options to select, and if we hit scan, you can see that it recognizes the position. We can turn the engine on and off and play the moves either by ourselves, see the engine eval, and so on. So this is the browser extension. Then the next thing is the ebook reader. So the thing I presented yesterday. So what it does is you can open a book from your computer, and this book is already analyzed by the app. So you can double click on any diagram in the book, and it will be loaded into the analysis board. So you can make moves on your own, turn the engine, see what it thinks. Also, it searches for games with that exact position. So you can see that 2 games were found here. So if we click on this, it will open the chess.com games database with those games. So yeah, there's a bunch of other functionalities here. So this is the ebook reader. The next thing is a Reddit bot. This is quite a popular tool as well. I can really quick show you what it does. So on Reddit, there is the chess subreddit, which is quite popular, and people like to post chess positions here, whether there are puzzles, some interesting positions from the games, and they discuss them in the comments. So the bot is automatically, it is analyzing the positions and provides some useful information. So there is a solution, there are hints with spoilers, so you can reveal them like that. There is the best continuation, there is the evaluation, and here it also recognized that the position came from a particular game. Here's the result of the game, and again link to the game. So it's doing this for all chess images posted on Reddit, actually. And the thing I will be talking about in this talk is actually analyzing videos. So let's say we have a video, whether it's a regular file or a video from YouTube, and what we would like to have is a PGN-like structure for that video. So this is an example output. So it's like a collection of three like structures corresponding to games presented in that video. So you can see that this is, you can see the highlights. This is the first position. The next one is the position that follows the first one. There is the move. And here we have timestamps. So when in the video that particular position occurred. Okay, that's the input and the output, but actually what we can do with that. So I prepared 2 demos. The first one is search functionality. So this is the demo prepared with just over 100 of videos from YouTube, and we can search them by chess concepts. So we can start with something very simple. So let's select French defense and advanced variation. And here are the results. And what's interesting is that the results are not only the videos, but actually the results point to the exact timestamps in those videos. So I'm not sure if you will be able to hear the sound. Just let me know if you can hear the sound when I play the videos, okay?
No, Pawel, I think you have to optimize it when you play from Zoom. There's an option to optimize sound.
Can you let me know how to do it?
I think when you take up the share screen option.
Okay, maybe now.
Whenever she
Yes.
plays the French, she's facing e5 a lot.
Okay, so there was sound, right? Okay, so you can see that this result is a French advanced variation. We can define many different filters here. For instance, there are some themes. Let's say we want exchange sacrifice.
And prepare this rook captures on c7. He gives up the exchange, but will really get a lot in return. Rook.
So this is the search functionality, and we can even combine those filters to have something quite complex. Let's say we want an endgame, and let it be, I don't know, king and pawn. And let's say we want a pawn sacrifice in such an endgame.
Problem is, after d5, it's a forced draw. If check, white is in Zugzwang. And then we reach a position where the pawn is in front, and this is just a book draw, nothing that...
Well, yeah, okay, so this is the search functionality. So this is the first thing we can do with this technology of translating videos to this PGN-like format. If you have any questions about that, you can ask now, or I can show the second application. Okay, so let me show the second one. By the way, you can try these demos for yourself. Just go to search.chessvision.ai to try search, or here's the other demo, but I will actually show it with a YouTube video. So let's open a YouTube video.
Beth Harmon.
Okay, so you can see the video here, and the thing on the right side is a chess analysis board that is synchronized to the video and automatically generated from that PGN file. So there is an engine and other options. You can turn the engine on and off. An interesting thing is that the games presented in the video are actually here presented as separated games. So you can see there is a game 1, game 2, game 3, and so on. And all those moves and games are clickable. So we can, let me click on this, and you see
an example taken
it
from
jumped in the video to the second game. Yeah, so if we play the video,
top 5
the board
moves.
will actually synchronize to watching the video.
She is the star of the Netflix show Queen's Gambit. Make sure you go and take a look at it. It's absolutely brilliant. Now, from one ginger to another, we're going to go and take a look at those kind of guys she found state championships. And here, Towns, he squeezed that rook until it had no squares to go to.
Yeah,
first
so
she
we
plays
actually
king g7.
So that this was
that
a really
rook
bad move.
Can only move to h5. Had the rook move to h4, knight to f3 check, forks the king and the rook, leading to a winning position. So rook to h5 is now met by king to g6. This shows the power of having a knight in the center of the board. The rook tries to escape over to a5.
Yeah, and we can actually stop the video at any moment and make move on our own, and you can see that the sync is now turned off, and we can play the moves by for ourselves, and we can turn the sync on at
those
any
knights
time.
are tricky little guys, and knight to b3 picks up the rook with a winning game.
And let's say we now want to jump to the last game, so we click on game 5, and
the last best sequence was her, shall we say, brilliant game at the end of the series against the Russian player Borgov.
Yeah, so yeah. I think it's clear what it does. So these two are the application of this technology of translating the videos. And next step, what are the next step with this? So we can add this in-video search to existing chess video databases. So for instance, let's say chess.com have their own lessons. So we can add this in-search videos there, or add this synchronized analysis board to any existing chess video database. And with this, we can also do this on YouTube, as you can, as I presented just now, with this browser extension. So this is actually a browser extension that you can install, and use it like that. Yeah, and maybe there are any other applications of this, but these two are what I so far done. Yeah, so I think that would be all regarding this. I can also show you two a very little projects I did just recently. The first one is these two projects are unrelated to this presentation completely, but this is quite popular post from 2 weeks ago. I did a study about chess pieces lifetime expectancy. So we take all the pieces that are in the game, and let me just make the image bigger. And this is the data from over 400,000 games from lichess, excluding blitz games, and only from games from players above 2000 rating. And it shows the average, let's say, lifetime expectancy of chess pieces in those games. So it's pretty interesting, actually. Obviously, kings live longest, and it actually means that the average game lasted for up to 44 moves. Yeah, so this is the first study, and it was quite popular on the internet, as you can see here. And the second one, it's there. It's pretty raw form, but what I did is that I computed the average number of captures per move by ELO rating. And this is the plot showing this. So you can see that there is a correlation between ELO rating and the average number of captures per move, which is really interesting and maybe useful for someone. Should I make it bigger? Maybe. And this is from the same data set. So actually maybe over 1 million games or 2 million games, but from the same database. There is this lichess masters database, which is really, really handy to use for such purposes. Yeah, and maybe the last thing is that it's a bit connected to what Martin was presenting, this tagging functionality. So for this search app, this one, I obviously had to have some tagging functionality to tag the positions. So maybe we have something in common there. what I did here is opening names. This is easy. There is game phase. So there is opening, mid game, and end game. Position open as. This is a really interesting feature. We have pawn structure. There are plenty here. And there are themes. And some of them are easy to implement. Some are a little bit tricky. And I find that using the static exchange evaluation from Chess Engine is really useful to implement some of them. For instance, exchanges, because we would like to take a look at a sequence of moves at a particular square. Yeah, so I think that's all, and thank you. And if you have any question, please ask.
So where's John? John, hello?
Ah, right, yeah. Sorry, I was just giving a very elaborate speech to myself with the microphone switched off. It was great. You should have heard it. Yeah, thank you, Pawel. That was a great tour de force. I think that I don't want to miss out the opportunity for each of the people that were on our list to make a contribution. So Albert Silva is also on the list. I don't know, Albert, if you wish to say something. I think you're here in the group. I'll just double check. Wants to speak.
Albert is also muted, I think.
Yes, he is. Yes, he is also muted. Let's see. I don't hear anything. Well, that could be for any number of reasons. Okay, so
I figured that out.
Oh,
yeah, sorry. I had this little button. I didn't know if it was your screen, if it was my screen.
All right, I know it's very
saying click on unmute, and I thought, oh, is he clicking it? Why doesn't he click it? And then I realized I was the one who had to do it.
Yeah, that's right. Yeah, that's great. Albert, anyway, very good to see you. We've had some tremendous contributions until now, and so would you like to just I mean, you've been doing so many different things in chess over the years, and you were last seen when DeepMind were developing their sort of breakthrough products. So would you like to say a bit more about that?
Well, I've obviously worked in chess for, oh my goodness, so many years. Working as an editor, as an interface designer, more recently in neural network development, modeled on Delia and DeepMind and AlphaZero, just like everybody's been fascinated. And the Maya group has clearly been taking up that that baton. I will say that I created a neural network based entirely on human games as well about 2 years ago, but not modeled on their own idea, which was to imitate human play at the lowest levels as a human opponent, but really just as to see what kind of neural network would develop based on the AlphaZero technology and their algorithms. And what I did was I took a database of millions of cold human games from Mega Database of 2,200 ELO and above, and using their normal algorithm, trained it entirely on that. And because, of course, contrary to the Lila and AlphaZero models, there is no policy data, which that means is that it doesn't have any evaluation information on the per move. So everything is trained only on the results of the game. If a player with played e4 and he won the game, then everything on his side of the board will be rated positive. And of course, vice versa. This is a debated issue on whether this is a problem or not, but eventually it kind of evens out. If you have enough data, if you have billions of moves, the results will sort of, let's say, fill in properly. However, the play didn't really model a human player as much as I had hoped. I thought that it was going to come out looking maybe as sort of like a human grandmaster playing at the highest level, but of course at a much stronger level because of the calculations involved. The trick is that the algorithms actually don't really do that. What they do is they seek to use the information, create pattern recognition, and from that reach, let's say, an optimal play, a Nash equilibrium, which is basically to try to find the best move possible in every situation based on the information it studied. So yes, it didn't play exactly like Leela, but eventually it started to play very much like Leela. The differences weren't sufficient for me to be able to say, oh, well, see, this is clearly a human network trained on human games compared to theirs, which was trained on pure self-play. I think that this is really a problem, or let's say an aspect of the actual neural network itself and their technology, which seeks to do this. It's constantly seeking to try to build the best data possible. So congratulations to Maia for having found ways to be able to limit this. There are a number of techniques, obviously, to be able to limit the information, which I asked them about in data inside of the chat. And a lot of this was basically because I'm familiar with a lot of the ideas since having tried them myself, although not having developed it specifically as deeply as they have. So again, kudos. As to, I'm afraid I missed out on Pawel's talk. My computer decided to do a wonderful blue screen of death, so apologies, Pawel. I'll get back to you and look at your information later. A lot of the work here is fascinating, and I'm really very encouraged to see so many different aspects of it involved. My personal work has been involved in trying to build basically just the strongest possible chess engine, which is not a new idea, of course, and based on the technologies that evolved and using different ideas. I'll be releasing a new version of what has become Fat Fritz 2, which is now going to be using the new NNUE neural network technology that was recently been filtering in chess through Stockfish, but is actually comes in from our Japanese friends who actually developed this for their shogi engines some years ago. So anybody who thinks that this is some new Stockfish thing, absolutely it is, at least the implementation. This is actually a gift from the shogi world. And of course, we'll be seeing a lot of that in the next months and maybe even a couple of years. Actually, what's fascinating is to see how quickly things are changing, because I think that everybody thought that after Leela and AlphaZero brought in their deep neural networks to the chess world, and of course to many other fields, that this was the latest thing, this was the new revolution. We wouldn't be seeing any kind of impactful revolutions anytime soon, at least not on that level. And yet, 2 years later, we're looking at a new technology, a leaf that is just crushing the previous one, and it just shows how quickly things are changing. And obviously, this is going to impact us on so many other levels. I will say that I'm really interested to see Delia's work on how it pertains to describing what is artistic, because frankly, that's a difficult topic to really define. You can say that yes, the first thing is to have, let's say, to remove all non-essential pieces, and sure, that would be one aspect, but that doesn't make something beautiful. If just removing everything that was non-essential was beautiful, well then my workspace would be beautiful, and I don't think it's beautiful because I removed everything that was non-essential. Originality and other things will be involved, but I look forward to seeing how that pans out. Martin, your work on your puzzles is fascinating. It's not new. Obviously, creating puzzles is not new. I didn't really understand, honestly, all of the what really differentiates it from some of the other ones. I understood that you're doing different things, and of course, these are your own ideas. But yes, anything that will help chess players find work that is adapted to their needs and are able to use this to springboard onto the next level is, of course, always wonderful. That's really all I had to say. I didn't want to take up time because I don't have any new breakthrough paper to share with everybody, as many have been doing here. But all the best. If you have any questions, of course, please feel free.
Yeah, thank you very much, Albert. I mean, which is, I think, a very nice overview and a summary of our previous speakers. I'm just looking for the buyer for Maia. Yes, they're still here. Yeah, so maybe you'd like to respond to some of the questions because you were the first up to speak, and you may have got some answers now.
Yeah, my first question really had been on how they were able to differentiate the lower levels from the other, let's say from 1300 to 1500 to 1700 ELO. It's not an obvious task at all. A lot of engines have been trying this over the years, very unsuccessfully. In fact, my personal experience as a chess player, and I am a chess player, has been very frustrating with the classical engines such as Stockfish, Ribka, and many other engines before. And basically it comes down to, oh, we're going to have the engine blunder at X number of moves. And really what you end up finding is that you're playing yourself against, let's say, a god of chess. It's as if Kacprzak were playing against you. And we played 5, 6, 7 perfect moves. And suddenly he drops a queen. And you're like, wait a minute, that's ridiculous. He's not playing me on my level. He's making a mockery of my chess, you know. And it really felt a bit like that. It didn't feel like I was playing a player of my level. And sure, oh, now that I have a queen up, I have a chance. But yeah, it wasn't a satisfying experience. So the idea of having an opponent that's at least beginning to play moves that seem much more human-like, at least on an error level that reflect more on the kinds of errors I would expect to see from players of my level or whatever the level might be, is going to be very satisfying for human players who want to test out positions, because people will say, well, I can play online nowadays. Why would I need this engine of 1500 ELO? Sure, there's a bot that plays 1500, but I can snap my fingers, go online and play 2000 players of that ELO. But it's not always that simple. Suppose you want to test an opening, but suppose you want to do it without the competitive, let's say, environment of an online player. Perhaps you want to be able to pause the game at any given time. So all of that's going to be wonderful. And I'm sure that Reid and Ashton's work is going to see a lot of happy results.
So Ashton, I think you look like you're about to say something or be prompted.
I was just going to answer if there were any questions. But yeah, no, totally, Albert. I mean, I've had the same experience. I think all of us playing engines have the same experience. I mean, if you haven't already, we'd love to hear your feedback on playing Maia. We've had a lot of people kind of say exactly that. They're like, Maias kind of feel like much more human than before. Like they're making kind of positional errors of the kinds that you would expect at the various levels. One thing I'll just mention that we didn't have time to talk about in the talk was that the only difference, as you were asking about in the chat, is that we trained on different data sets. So data sets of like 1100 players were fed into Maia 1100, and data from 1500 players were fed into Maia 1500. And as a result, there's like completely non-overlapping data. So not a single game was shared between the Maias. One thing that was cool was that on all of our test sets, so we had a different test set for every rating level. And we can just apply every single Maia model to every single position and just see how much they agree with each other and with other engines like Stockfish and Leela. And it turns out that the various versions of Stockfish and the various versions of Leela, they don't really agree with each other very much, but the different versions of Maia are like in super high agreement, even though they do vary a little bit to get the different levels that we talked about. But it just seems like the Maia moves are in a completely different part of the space that arguably is more human.
I was going to suggest that one method that I had entertained some years back was to actually try to calibrate an engine according to the error rate. Now, this was pre-Leela, and so the neural networks didn't exist. And the idea was to take, let's say, a rating group of, let's say, 1300 to 1500, and run it through the engine and see the average center pawn error they were creating, they were generating over the game, as well as the level, how many blunders, and then try to find a way to get the engine to produce that. I didn't find a practical way to do it, but it's one way, at least, maybe not to produce an engine, but at least to measure it. Humans, you might find out that maybe 50% is as good as you can get, because the 1100 players don't really have a consistent move output. You know, the difference of humans is just big enough that even 10 other human players of 1100 won't match those that 1100 group either. You know, so
Yeah,
it might be a factor.
Right. I do think kind of before all this data came around, that's kind of the best thing you could do, is just like the aggregate kind of like error rate. But now that we have the exact moves that people are playing, we can just do a lot better. So yeah, it's really a data issue.
I look forward to it, and I will try the engine out.
Great, thanks. Yeah.
Does anybody else have some questions of the speakers while we're here in the last few minutes of this session? We're supposed to end at 1/2 the hour.
I wanted to ask a quick question to Pawel, actually. I was just curious how many videos you've indexed, and if that's expensive, like how do you actually do all this searching?
Yeah, so the search is actually just over 100 videos, so it's not that many.
Okay.
And processing one video is, an average video, let's say 15 minutes, 15 to 20 minutes is around 3 minutes. So it lasted a bit, but not that much. And what I'm thinking about is that I can observe the new videos that are being published on YouTube, and then analyze them as soon as they are published. Yeah.
Cool. And are you doing something like, I know if you were to do every single frame, that would be super expensive. So are you doing something about picking the right frames to analyze?
Yes. So essentially, the algorithm works like that. First, it tries to find the first frame with a chessboard. Okay. And then for some time, we have that assumption that the chessboard remains in the same position in the frame. Okay. That may change when, for instance, the lecturer drags the board somewhere else, right? But for now, we assume that the chessboard stays in the same position, because actually what's the most expensive operation is finding the chessboard. When we have the chessboard, then we can divide it into 64 squares and feed those 64 images to a neural network and just recognize the chess piece and the color. Okay, so the expensive operation is to find the chessboard, and we want to avoid finding the chessboard many times. So a useful thing to do is to take a look at consecutive positions. So if we have consecutive positions from the same game, the difference is, the delta between those positions is small, right? So it would be maybe up to four cells, maybe 4, maybe 5, something like that. So we can have that heuristic that if the delta is larger than, let's say, some threshold, okay, then we can try to find the chessboard again, for instance, and it works really well, I guess.
That's awesome.
Are you able to? Sorry, I was going to ask.
Or a final question, and then I'm going to have to draw the meeting to a close.
Pawel, does your technology work with non-digitalized computer chessboards? I mean,
no,
if you take a board, let's say with one of those presentations, even let's say from Casino Royale or some other movie, would it recognize the board?
It works as long as the chessboard is two-dimensional, let's say. So it can be something that is hanging on the wall, let's say, but it has to be two-dimensional. It can be rotated, skewed, that's fine, but the pieces have to be two-dimensional. Yeah.
Okay, good.
Okay, so as we leave the two-dimensional world and return to the three-dimensional or even four-dimensional world, that fourth dimension is catching up with us at the moment. I think we'll draw a close here. I'd like to thank everybody, the speakers in particular, for excellent talks, brilliant content. And I would thank everybody for attending the event, supporting the event, because I think by bringing people together, we accelerate even more the wonderful things that's being done by chess and technology. Okay, all the best, and enjoy. Well, there isn't much of the conference left, but do pop along. And of course, I just mentioned that we have a kind of cafe. In my mind, it's downstairs, but you click on the link, and that's where a number of us hang out from time to time and have a chat. Okay, all the best. Bye-bye.